Introductory Statistics Module 10, Hypothesis Tests Regarding a Parameter. Section 10.1, The Language of Hypothesis Testing. We will look at these three objectives in this section. Objective 1, determine the null and alternative hypotheses. A hypothesis is a statement regarding a characteristic of one or more populations. In this chapter, we look at hypotheses regarding a single population parameter. Here are some examples of claims regarding a characteristic of a single population. The first, in 2008, 62% of American adults regularly volunteered their time for charity work, and a researcher believes that this percentage is different today. In the second one, we see, according to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. And third, using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So the key words here, in the first one, we see the word different. In the second one, we see the word increased. And in the third, here we see the word decreased. So those are going to be important as we look at our hypotheses. First, a caution. We test these types of statements using sample data because it's usually impossible or impractical to gain access to the entire population. But if population data is available, then there's no need for inferential statistics. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. So let's look at the steps to doing hypothesis tests. First, we make a statement regarding the nature of the population. Second, we collect evidence or sample data to test the statement. And third, we analyze the data to assess the plausibility of the statement. So let's look at some definitions. The null hypothesis, denoted with an H with a subscript of 0 or H naught, is a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. The alternative hypothesis, denoted with an H of a subscript of 1, is a statement that we are trying to find evidence to support. In this chapter, there are three ways to set up the null and alternative hypothesis. First, we have equal versus not equal hypothesis, and this is what we call a two-tailed test. So we have that our null hypothesis states that the parameter is equal to some value, and the alternative hypothesis states that the parameter is not equal to some value. The second way, we have equal versus less than, and this is what we call a left-tailed test. Our null hypothesis says that our parameter is equal to a value, whereas the alternative hypothesis says that parameter is less than that value. And third, we have equal versus greater than. We call this a right-tailed test. The null hypothesis says that our parameter is equal to our value, and our alternative hypothesis says that our parameter is greater than that same value. So in other words, the null hypothesis is a statement of status quo, or no difference, and it always contains a statement of equality. The null hypothesis is assumed to be true until we have evidence to the contrary. We seek evidence that supports the statement in the alternative hypothesis. So let's look at an example where we'll actually form our hypotheses. For each of the following claims, determine the null and alternative hypotheses, and state whether the test is two-tailed, left-tailed, or right-tailed. So this is part A that we looked at earlier, where we have 62% of American adults regularly volunteering their time for charity work, and a researcher believes this percentage is different today. So the key word here is the word different. and we're dealing with a proportion. So if the percentage participating in charity work is no different than in 2008, it will be 0.62. So what we have then for our null hypothesis is that our p-value is equal to 0.62. And we use the value p because we're looking at a proportion. Since the researcher believes that it's different, then this would mean that our alternative hypothesis says that our p-value is now not equal to 0.62. And this is what we call our two-tailed test, when we have equal or not equal. In part B, according to the study in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that this mean length of a call has increased since then. So notice that this is dealing with a population mean, mu. So if the mean call length on a cell phone is no different than in 2006, then it will be 3.25 minutes. So we have that our null hypothesis then is stating that our mean mu is equal to 3.25. And then notice that our researcher believes that the mean length has increased. So that's our key word there to let us know that our alternative hypothesis says then that the mean is greater than 3.25. And this then would be our right tail test. And then for part C, using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So this hypothesis test deals with a standard deviation, sigma. If the standard deviation with new equipment has not changed, then it will be 0.23 ounces. So our null hypothesis then, we're dealing with a standard deviation, is sigma is equal to 0.23. But then the quality control manager believes that the standard deviation has decreased. So that lets us know that our alternative hypothesis is that sigma is less than 0.23. And in this case, we're using a left-tailed test. Objective 2, we want to explain type 1 and type 2 errors. There are 4 outcomes from hypothesis testing. 1, we reject the null hypothesis when the alternative hypothesis is true. This decision would be correct. 2, we do not reject the null hypothesis when the null hypothesis is true. This decision would be correct. 3, we could reject the null hypothesis when it was actually true, and this decision would be incorrect. This type of error is called a type 1 error. And fourthly, we could not reject the null hypothesis when the alternative hypothesis is true. This decision would also be incorrect, and this type of error is called a type 2 error. And here we see a picture of these errors kind of laid out a little more simply for us. So we have to see that our 2 correct conclusions are that we do not reject the null when it was true, or that we rejected the null and the alternative was true. Those would be correct. Type 1 is where we reject the null, but it was true. And type 2 is where we don't reject the null and the alternative is true. So let's look at another example using our errors. For each of the following claims, we want to explain what it would mean to make a type 1 error and then what it would mean to make a type 2 error. So part A for our first one deals with the 62% of American adults regularly volunteering their time for charity work. And our researcher believes that this is different today. So remember that a type 1 error occurs when we reject the null when it was actually true. So a type 1 error is made if the researcher concludes that the proportion is not equal to 0.62 when the true proportion of Americans 18 years or older who participated in some form of charity work is currently 62%. And then the type 2 error is where we do not reject the null when the alternative was true, meaning that it was different. So a type 2 error is made if the sample evidence leads the researcher to believe that the current percentage of Americans who participated in some form of charity work is still 62%, when in fact this percentage is different today. For part B, we're looking at our mean length of phone calls on a cell phone, and our researcher believes that the mean has increased since 2006. So a type 1 error, we reject the null when it's true. A type 2 error, we don't reject the null when the alternative is true. The type 1 error occurs if the sample evidence leads the researcher to conclude that the mean is greater than 3.25, when in fact the actual mean call length on a cell phone is still 3.25 minutes. And then a type 2 error occurs if the researcher fails to reject the hypothesis that the mean length of a phone call on a cell phone is 3.25 minutes, when in fact it is longer than that. So take note that we never know whether the conclusion of a hypothesis test is correct. However, we can determine the probability of making errors when testing our hypotheses. So this is kind of commonplace notation for that. Alpha is the probability of making a type 1 error, which means the probability we reject the null when it was true. And beta is the probability of making a type 2 error, or the probability of not rejecting the null when the alternative hypothesis was true. The probability of making a type 1 error, alpha, is chosen by the researcher before the sample data is collected. So we call this value alpha the level of significance, which is the probability of making a type 1 error. In other words, as the probability of a type 1 error increases, the probability of a type 2 error decreases, and vice versa. Objective 3. State conclusions to hypothesis tests. We need to exercise caution. We never accept the null hypothesis because without having access to the entire population, we don't know the exact value of the parameter stated in the null. Rather, we say that we do not reject the null hypothesis. This is just like the court system. We never declare a defendant innocent, but instead we say the defendant is not guilty. So here let's look at an example where we will state the conclusions from our tests. And we're again using the example with our cell phone data. In part A, we want to suppose the sample evidence indicates that the null hypothesis should be rejected. We want to state the wording of the conclusion then. So notice that we have two sentences here. The first one saying that the mean length of a phone call on a cell phone was 3.25 minutes. That is the null. The second sentence is where the researcher believes that the mean has increased. That's the alternative hypothesis. So if we're going to reject the null, then you can think of it as sort of like crossing out this first sentence. So then we're going to focus on the second one. And the way we would word it is to say that then there is sufficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. And in part B now, we're going to suppose that the sample evidence indicates that the null hypothesis should not be rejected. And we want to state the wording of this conclusion. So if our null is not rejected, then that means we're going to reject the alternative. So we're going to cross that sentence out. And so then we're going to focus on backing up our null hypothesis. And the way that we would word that is to say that there is insufficient evidence to conclude that the mean length of a phone call on a cell phone is greater than 3.25 minutes. Or in other words, the sample evidence is consistent with the mean call length equaling 3.25 minutes.